In this video, we're going to learn how to find the exact value of an inverse trigonometric function. We'll start with the definition of an inverse trigonometric function. So, if a normal sine function, by plugging in an angle, would yield some sort of value, usually denoted by a y value of the coordinate on the unit circle, then if we plug in that value into an inverse function, it should yield an angle. Now it goes true for all of them, for cosine and cosine inverse, for tangent and tangent inverse. The really important thing to note is that the angles that you get from plugging in a value have to be bound between a certain range. Because these are periodic functions, we can't have like multiple answers for plugging in one number, or else this would no longer be a function. So let's get into this first example. So we have sine inverse of 1. The way you can also read this, if this is equal to some angle, what we're trying to figure out is by plugging in by what angle sine inverse, the sine of theta, is equal to 1. Where does that equal 1? And we're going to be bound between these two particular angles, negative pi over 2 and pi over 2, which is negative 90 degrees to 90. So where along this range in these red angles here in the circle would sine be equal to 1? And 1 is the maximum of sine. So it would be the highest point, which would be this pi over 2. So sine inverse of 1 is equal to pi over 2. That's how you evaluate an inverse trigonometric function. Now, if I was looking at this problem here, what that means is what angle would make sine equal to negative 1/2? Now, sine is negative in both the third and fourth quadrants, but we're going to focus on this fourth quadrant and use these negative angles. So usually this would be 11 pi over 6 on the unit circle, but we're going to use negative pi over 6 as the angle that would make sine negative 1/2. So sine inverse of negative 1/2 is equal to negative pi over 6, since that would be the angle that would yield that value for sine. Again, you're getting angles when you plug in values into inverse trigonometric functions. For cosine of 0, the logic would be what angle would make cosine 0, which we know happens at pi over 2 and 3 pi over 2. But we're not going to use the bottom one because our range is going to be from 0 to pi, or 0 to 180 degrees. And we're going to pick some angle along that stretch of angles. And at pi over 2, the x value is 0. So it would make cosine 0. So cosine inverse of 0 would be equal to pi over 2. Next up, we'll have cosine inverse of negative square root 2 over 2. Again, same logic. What angle would make cosine equal to negative square root 2 over 2? It wouldn't be pi over 4, because it would be positive square root 2 over 2. But we'll go to the second quadrant at 3 pi over 4. The x value is negative, and that would be negative square root 2 over 2. So cosine inverse of negative square root 2 over 2 is equal to 3 pi over 4. Even though it would also be negative square root 2 over 2 at 5 pi over 4, the range of these inverse functions only spanned 180 degree rotation. Now, tangent inverse of 1, we're looking for where is tangent equal to 1. So I'm going to use the range here of negative pi over 2 to pi over 2. So all these red angles. Tangent's positive, so I'm going to be in the first quadrant. And it's 1 wherever x or y are the same value, because tangent's y over x, which would happen at pi over 4. Square root 2 over 2 over square root 2 over 2, which would be 1. So tangent inverse of 1 would be equal to pi over 4. And lastly, if you have tangent inverse of negative square root of 3, we're looking for where is tangent of theta equal to negative square root of 3. Well, it's negative, so it's going to be in the fourth quadrant here, because it's where tangent's negative in the second and the fourth quadrant. But since the range of tangent is negative pi over 2 to pi over 2, we're going to have to look at some angle in this quadrant. And negative square root 3 would be the one that happens at 5 pi over 3 or pi over 3. But since I'm looking at these negative angles, the tangent inverse of negative square root of 3 would be equal to negative pi over 3. That would be negative square root 3 over 2 over 1/2 if you're looking at the x and y coordinate. And that would be the value of tangent inverse of negative square root of 3. And that is how you find the exact value of an inverse trigonometric function.